Okay, so welcome back to example 4 in our notes for intervals of increasing, decreasing, and constant. In example 4, we're looking at a rational function, and it's important to remember, just like when we talked about our extrema notes, that horizontal asymptotes, because the graph is approaching but never touches the horizontal asymptote at the right or left ends, that it is in this example, it's always decreasing here, right, from the vertical asymptote at 2 off to positive infinity. Even though it visually looks like it's becoming horizontal, it never actually is horizontal because it's always forever approaching that horizontal asymptote. So this function, as we read from left to right, it's increasing over the interval negative infinity to that vertical asymptote at -2. And then we have a union, and we can see this section of the curve is increasing as well from the other side of that vertical asymptote at -2 until we reach this relative maximum here at x equals 0. Then at 0, it turns from increasing to decreasing and continues decreasing as it approaches this vertical asymptote at +2. Then we hop over the asymptote and it's still decreasing, but from up here at infinity in the y direction, it's decreasing now until positive infinity. So 2 to positive infinity would be our second part of the decreasing interval. And we know that it's never going to actually become horizontal because it's always approaching this horizontal asymptote. And so for interval where the function is constant, that's a none because it doesn't exist. Okay. And if you would try this example, this is another rational function. You're going to use graphing technology to sketch the graph and then determine is the function increasing, decreasing, and or constant, and over what intervals. So go ahead and pause the video, and when you're ready to check your answers, you can resume. Okay, so let's go ahead and try this one together. I'm going to go to the y equals, and my numerator is a monomial, so I don't need parentheses around it. And that'll be x squared divided by. The denominator, though, is not a monomial, it's a binomial, so I need parentheses around that denominator of x plus 1. Okay, then zoom 6 will show me a standard -10 to 10 viewing window, and I can see there's my vertical asymptote at -1, and this graph has what we learned in the last lesson is called an oblique asymptote or a slanted asymptote rather than a horizontal asymptote. And I can see as I read the graph from left to right that it is increasing. It starts out as an increasing function up until this relative maximum. But to know where that interval is, I'm going to need to use my second trace to open the calculate menu, and we're going to find the extrema. I'm going to start with this maximum by arrowing down to number 4 and pressing enter, and then my left bound for this maximum looks to be let's see here, we'll arrow over to probably -2, -3, let's do -3 and press enter, and then the right bound, so a point to the right of it, looks like probably somewhere on the left of -1 because -1 is my vertical asymptote. So I'm going to do, say, -1.1 and press enter, and then I press enter for the guess, and there's my relative maximum of -4. Okay, the x value at that maximum would round to -2, and if I check my table, second table, that should show me if -2 is the value, and sure enough, there -2 comma -4 is my relative maximum. So negative infinity to -2 then would be the interval where that graph is increasing. So increasing over the interval negative infinity, comma, negative 2. Okay, when we look back at that graph again, we can see then that it turns and is decreasing from negative infinity, or sorry, from negative 2, and then it heads down toward negative infinity in the y direction, but the x value that that's approaching is that vertical asymptote at negative 1. And when we look at the table, right, we can see at negative 1, there's an error, that's that vertical asymptote. So this function is decreasing from negative 2 to negative 1. Okay, then we'll go back to that graph again, and we see that on the other side of that vertical asymptote at negative 1, it is decreasing until we reach this relative minimum here. And I'm going to do second trace and see if I can approximate that minimum value. So my interval there would be on the right side of the asymptote, so negative 1 is the asymptote, so negative 0.9, for example, and then a point to the right might be positive 1, and press enter for my guess. Okay, and then remember when we see E, right, that's scientific notation, and it rounds here. E to the negative 7 would be 7 zeros in front of that negative 5. E to the negative 13 would be 13 zeros in front of that 2. And so, our place values, so we know that these would round to 0, 0. So if I check my table again, right, there's the 0.00 that I can see would be my relative minimum. So the function then is decreasing from that vertical asymptote at negative 1 until x equals 0, and then it turns to increasing, picking up at 0 and heading off to positive infinity. Okay, so I would use that information then to sketch the graph, and that graph would be having its extrema then at those 2 points that we just saw. So if I slide this over here out of the way, then we can go ahead and make a rough sketch of our graph. So at negative 1, negative 2, negative 3, so negative 1, here's our vertical asymptote, and then positive 1, 2, and 3. And then we've got a point here at the origin, and we have another point here at negative 2, at negative 2, and then down here to negative 4. And then we've got a slant asymptote. So we don't need to be super accurate with the slant asymptote at this point, because we'll learn more about those in our next lesson. So this would be the rough sketch of our rational function. So that brings us to our secret question for this lesson. So you're going to use graphing technology to graph the function f of x. Just a rough sketch like we did in the last example. Identify your intervals of increasing, decreasing, and constant. If it turns out that there isn't an interval for one of these, you would just write none, right? Like in our last example here, there was no interval for a constant section of our function, and so we would just say none for that because they don't exist. Okay, so you're going to go ahead and solve the secret question and then upload your answer as the last page of your notes to the Dropbox in Schoology.